Newton Damilare Adedeji, a physics teacher in Songo Senior Secondary School at ABA. So as promised, today we want to look at our possible question on mechanics, physics practical this year. So without taking much of our time, we have our instruction on the board and the corresponding diagrams. So as usual, let us first identify all of our laboratory apparatus. So from here you are provided with a meter rule. This is a meter rule. A knife edge. This is a knife edge. Set of masses. These are our set of masses. These are our set of masses. A retort support. This is our retort support. An inextensible spring. This is it. And other necessary apparatus. So we also have our thread here and our sellotape. So now let's go straight to the work. Place the meter rule on the knife edge. Of course, we have identified our knife edge. So we want to place the meter rule on the knife edge. Read and record the point G. So we are dealing with the first figure. This is the knife edge and this is our meter rule AB. So we want to record the point G where the meter rule balances horizontally as shown in this diagram above. So let's do that first. So now this is our knife edge. This is our meter rule. So let's try to look at the point where this meter rule will balance horizontally, and that is our point G. So I'm trying to balance it. Let me quickly say this. There is what we call uniform meter rule. So when a meter rule is uniform, of course the balance point will always be the 50 centimeter mark, unless if the meter rule is not uniform, or probably the knife edge is 40. So from here, let's look at this very well. So our G point is the 50 centimeter mark. So let's look at it. You can all see that the meter rule has balanced horizontally. So that's our G point. From this diagram, the G now is 50 centimeter mark. Okay, let's go to the next instruction. Suspend the meter rule at G. Remember that our G is 50 centimeter mark. So we are to suspend the meter rule at G with the aid of the string provided and attach the string to the retort support as shown in the diagram. So this is the next diagram we want to do. So we are to support this meter rule with this string. So what it means is that we are going to do it at the G point. Now remember that our G, after we balance it on the knife edge, is 50 centimeter mark. So I'm going to attach this meter rule. I'm going to attach the extensible meter spring, to the meter rule at the G mark. So if you look at it very well, our G mark is at 50 centimeter mark. So let's try to fix the spring there, after which we are going to suspend it from the retort support. So I'm trying to fix the spring. Trying to fix the string to the G spot, and that's the G mark is 50 centimeter. Let's not forget. Okay, so let's try to extend it from our retort support. This is our retort support. So I want to try to fix the meter rule to it with the aid of the string. So that's what we're trying to do this afternoon. So I really want you to follow up with the class, because it's a very interesting practical, and trust me, it is very, very easy. Very, very easy practical. Very, very easy practical. So yes, now by suspending it from the 50 centimeter mark, there is every tendency for our meter rule to dangle. So when it dangles, so there's every tendency for it to dangle. Okay, that is it. First instruction, and I've carried this out. So I've been able to suspend my meter rule with the aid of this string. Yes. So this is the next thing. Now this composer, you can see that the string is attached at the G mark, and the G mark is 50 centimeter. Okay, good. So now let's try to read the next instruction. So the next instruction says that, okay, suspend the meter rule at G with the aid of the string. This is what we have done. And attach the string to the retort support as shown in the diagram. This. Keep the string attached to this point throughout the experiment. That is, we are not going to change it. this is how we are going to have our meter rule suspended throughout the experiment. Now, attach the mass M naught. Look at our mass M naught. We are to attach it at the 80 centimeter mark. So what do? We get our sellotape or paper tape, as the case may be. Now everybody see, this is our mass M naught. We are to suspend it at the 80 centimeter mark. So it's good that it sits horizontally. So we look at the center, we try to fix it on the meter rule. So that is our 80 centimeter mark. So let's try to fix it properly to the 80 centimeter mark. Yes, we can use the aid of our sellotape or paper tape, as the case may be. Yes, so that is the instruction, and that's what we have done. And of course, we will expect it to come down this way because of the weight on this end. Yes. Now the next instruction says that determine the distance y of M naught from G. So who can tell me what the distance y from M naught from y of M naught from G? Of course, this is M naught. Look at the diagram. The M naught is attached to the 80 centimeter mark. Yes, if you look at it very well, I showed you that this M naught is at the 80 centimeter mark. Remember, this is 100 centimeter. So now, what is our distance y? The distance y is from the G centimeter mark, which is 50, to where the M naught is, and that's 80. So if you look at it, from 50 to 80, our y will give us 30 centimeter. So our y is 30 centimeter. That's from 50 to 80 centimeter mark. Good. The next instruction that we are to carry out. So keep M naught at this position throughout the experiment. So this is where our M naught will also be throughout the experiment. So now let's proceed. So suspend the mass M is equal to 40 grams on the side AG. So this is side AG. And look at it, we are going to suspend it with the aid of our rope. So we are going to suspend it with the aid of our rope for it to be easy when we are moving it. And it will also help us to identify the right spot. So we are going to suspend 40 centimeter mark, 40 centimeter mass from any position until this meter rule balances horizontally. So we are going to do it together. Just follow what we are doing. From here now we are to suspend the mass M, this mass M, which is equal to 40 grams on this side. So which is the other side of our mass. So let's try to do that. This is 20 grams. I will add another 20 grams because the mass angle and this weight that is fixed is 20 grams. So this makes 40 grams. So let's try to suspend it from the other end of the meter rule. So what do? Because this has been fixed at our 50 centimeter mark. So we try to move this until it balances horizontally. No, this is not still balanced. So you keep on moving the weight until it balances horizontally. Alright. This is our 40 grams. So let's try to balance it horizontally. And of course, if you see now, it's not balanced. It is not well balanced because if you view it, one side is still good. So let's look at it from any angle. You see that this thing is at horizontal. So now the next thing for you to do is to look at the mark on the meter rule. So if we look at this very well, let's look at it very well. This is about 12.30 centimeter. This is 12.30. So the first one, let's take note of our mass in gram, and that's 40.00. So the next one, because from here, if you look at it, they said M is equals to 40 grams on the side AG, and adjust it its position until the meter rule balances horizontally, which is what we have here. So now, measure and record the distance of X of M. So what will be our X? The point where the M balances to our G. So now from here my mass is 40 grams and this balances at 12.30 mark. So of course what is going to be my x? Remember that this is at 12.30 mass. So what's going to be my x? That will just be, because this is 50. From 0 to the G mark is 50. So and this balances at 12.30 mark. So I will subtract it from 50. Simple. So you pick your calculator and say 50 minus your 12.3. So what do we have? We have 37.70. 37.70. So that is for our 40 gram mass. Good. Now we are to evaluate x minus 1. So what does that mean? That's x. Remember that our x is measured in centimeter. So our x raised to power minus 1 will also be per centimeter. So and that will give me 1 divided by my 37.7. So what do we have? We have 0. Let's take it to 3 decimal place. So we have 0.027. Good. So that's the first one. So now what do we do? Let's go back to our instruction. The next one, repeat the procedure for 4 other values of m is equal to 60, 80, 100 and 120. Very simple. So we are going to add more masses. Remember that as we are adding more masses, the distance will be reducing. So let me add more mass. The next one I want to do now, look at it. You can see that it's going down because there is more weight on this end. But we will try to balance it. So that's 60.00. Okay, so let's try to adjust it until the meter rule balances horizontally. Until the meter rule balances horizontally. Okay, so I'm trying to adjust it. Until the meter rule balances horizontally. Remember, this is our 60 gram. So we're trying to balance this horizontally. So let's see. Okay. If you look at it now, we have a balanced meter rule. And what mark is that? Let's read it again together. If we look at this is also at our 25.3 centimeter mark. 25.3 centimeter mark. So what do we do again? Remember, our G mark is 50 centimeter. So you just say again 50 minus 25.3 centimeter. So you have your 24.70. After that, we also evaluate the x inverse, and that's 1 divided by 24.70, and that will give us 0.040. That's 0.040. That's our x. Good. You can see how simple this practical is, and it's not time consuming. So let's go to the next one. The next mass is 80 grams. So I'm just going to add 20 grams to the existing 60 grams. So this is 80 grams. Of course it will come down because we have more weight here. So let's also try to do what? Adjust it. The way we have been adjusting it. So we'll try to adjust it until, if you look at this is not balanced. So you have to still take it back a bit until it balances horizontally. This is still not well balanced. So I have to adjust it until it balances horizontally. Let's look at this. We have a balanced meter rule. Let's see if we can still adjust it a bit. You have to be very careful when you are doing it because tiny adjustments may affect how the meter rule balances. So of course, if you look at it, it's looking balanced now. So what mark is this? This is at 31.5 centimeter mark. 31.5 centimeter mark. And of course, you know, for you to get your x is from the 50 centimeter mark to where the mass is. So what do? We just say 50 minus 31.5 centimeter. 50 minus 31.5 centimeter. Let's see. 50 minus 10. So that's for our 80 gram. So we have 18.5 centimeter. So what do we do again? We find the inverse, and that's 1 divided by 18.5 centimeter. So what do we have? We have 0.054. Good. The next one, 100 grams. So what do? I only add to the existing one again, 100 grams. You see, the weight will definitely come down. So I have to do what? Adjust it. So let's try to adjust it. This is 100 grams. Remember this is 100 gram, 20, 40, 60, 80 and 100. So we'll also be adjusting it until the meter rebalances horizontally. Okay? I think we are getting closer to the horizontal point. Alright, so if you look at this balances horizontally. If you look at it, this is well balanced. It has also balanced horizontally, and if you look at it, this is at, please come closer, this is at 35.5 centimeter mark. 35.5 centimeter. So the x will also be, the way we are doing it, 50 minus 35.5, and what do we have? We have 14.50, and this is 100.00. So what do we do? 1 divided by the answer. So we also have 0.069. 0.069. The last one is our 120 gram. So let's add it quickly and try to balance it horizontally. So this practical is simple and it does not really consume time. It doesn't really take time. As long as you know how to go about it. So this is our last one, and that's 120 centimeter mark. So we are trying to find the balance point. Okay, good. I think we have. This is at 37.85, or let's say 37.8 centimeter mark. So that will give me 50 minus 37.8 centimeter mark. So we have 12.20. Remember, this is 120.00. So what do we do again? We find the inverse, and we have 0.082, and that is our x minus 1. So what is the next thing? We are through with all of our practical. So we have evaluated our x minus 1 in each case. Now plot a graph of m. This is our m on the vertical axis and x minus 1 on the horizontal axis, starting both axes from the origin. Try it quickly so that we won't take time. So of course, you should know that the first thing is to draw your axis, and that is my x and my y axis. And I said it in my last YouTube video that once you draw your axis, always ensure to put the unit you are plotting and their the quantity you are plotting and their unit. So mass in gram, then the next one is my x minus 1 in centimeter minus 1. So the next thing is to pick your 0. So the next thing is to pick our scale. So this we have 120. So if you look at it very well, we have 20, 40, 60, 80, 120. So we can use 40 centimeter. Let's see, 40 cm. Let's use 4 centimeter for 20, 20, 40, 60, 80, 100, and we have the last one here, which is still fine. So let's use it so that we can cover 3 over 4 of our graph. So this is 20. This will give me 40. This 60. This will give us 80, 100, and the last point here is 120. Good. Now let's look at the next one. The highest value here is 0.08 and the lowest is 0.2. So of course I can say 2 centimeter to represent the 0.01 unit. So this is 0.01. This will give me 0.02, 0.03, 0.04, 0.05, 0.06, 0.07, and 0.08. So let's quickly write our scale quickly. On the x-axis, we have 2 centimeter represent the 0.01 unit. While on the y-axis, I have 4 centimeter represent 20 units. Now what is my graph? Let's look at the title of the graph. Now we have picked our scale. So let's quickly plot. So the first one is 40 centimeter and 40 gram to 0.027. This is my 0.02. So and this is my 47. 1, 2, 3, 4, 5, 6, 7. So this is my point. So the next one I have 60 gram to 0.04. This is my 0.04 to my 60. So this is our point. The next one I have 80 to 0.054. This is my 0.05. So 4. 1, 2, 3, 4 to my 80. So this point. Next one is 100. I have 0.069. So this is my 0.06. So 9 is closer to 7, at this point I have my 100. Then the last one, 120, my 0.082. So this is my 0.08212. So this is the last point. Okay, so let's try to join them together. Yes, let's try to join them together. What do we have? Let's try to join them together. Yes, so if you look at it, we have a straight line graph, although line of best fit, so and we have one mark on the other side, so which is very much correct. So quickly, let's determine our slope without wasting time. Let's determine our slope. So I pick 2 points, and as I've said earlier, make sure that your triangle is large. Make sure that your triangle is large enough so as to not confuse yourself. Make sure it's large. Examiners want to see your triangles large. So we know how to do the next one is with our dotted line. So we trace it down with our dotted line. So we want to determine the slope of our graph. So quickly. So let's trace it. So as I said in my last class, of course we know that what is our slope? We know that our slope is change in y over change in x, and that's y2 minus y1 all over x2 minus x1. So let's go back to the graph. What's our y2? 100. Our y1, which is this one, is 50. So we have 100 minus 50 all over. Let's go to our x. On our x2, I have 0.06 1 2 3 4 5 6 7 8. So 0.068 minus, let's go to my x1, I have 0.03 1 2 3. So 0.033. Okay, so this is 50 all over, yes, 0.068 minus 0.033. So I have 0.035. So let's divide that by 50. So what do we have? We have 1428.57. So I have 1428.6. And what will be our unit? That's gram per centimeter. Gram per centimeter. Remember that we are plotting G against x minus 1. Simple. So that is our slope. So let's go back to the graph quickly. Let's go back to the instruction. So now we have got a graph of that. We have also determined our slope S. So what's our slope? Our slope is 1428.6 gram per centimeter. Okay. Now, given that S is equals to, let's go back. So given that S equals to ym naught, we said we should determine our m naught. Remember that our S is this. That's 1428.6. Because what's our y? We have our y as 30 centimeters, then m naught. So my m naught will be 1428.6 divided by 30. So let's divide that quickly. Our answer divided by 30. So we have our m naught to be 47.6 gram. 47.6 gram. Good. Now, the last thing is to state our precautions. As usual, let us state our precautions. One, I've always told you, or I said it in the last class, that whenever we are using any apparatus that has calibration that we can measure from, of course, we must always try to avoid parallax error. So you have to write it in the important way. I avoided parallax error. Parallax error when taking readings on the meter rule. Good. Next one, you can say another one is I ensured that the meter rule is well fixed with the aid of the spring to the return support. So I ensured that I fixed the meter rule room properly to the retort support with the aid of the string. And another precaution that we can take from here is I avoided drag. So when you are doing mechanics, you can also avoid drag. So today this is the end of our class, and I hope that this little video that we have done, both on the electricity and mechanics, I know this has given you at least a knowledge of what is to come in the forthcoming WAEC. I wish you all the best. I am Mr. Yeviton Damilari. Please like, share and subscribe to my YouTube channel, as I will be posting more videos, especially on areas that are a bit tough in physics. Thank you and have a nice time.